Alright, let's look at the homework 4.3, problem number 7. Alright, so we want to find the interval increase and the interval decrease for part A. So let's do that. Alright, so we need to take the derivative. So f prime of x is equal to, alright, so x to the fourth plus 27, and derivative of that, put it on top, so just chain rule there. Alright, then set that equal to 0, and obviously we can just set the numerator equal to 0, so we get x equals 0 as the critical number. Alright, then we can do a number line and put a tick marks at 0, and then we look at the f prime. Right, so we can try something less than 0, so -1, and something greater than 0, +1. Alright, so if you plug in a -1 here, that's going to be negative, that's going to be positive because it's the fourth power, so you have a negative sign there. And if you plug in 1, that's going to be positive, that's going to be positive, so everyone's positive. Alright, so we know that the original function f is decreasing before 0, increasing after 0. Right? So that's why we have increasing interval increases from 0 to infinity. Interval decreasing would be -infinity to 0. So we got that. Right, so find the local minimum value. So you can see that a decreasing turned into increasing. So we know that definitely you're going to have a local minimum there. Right? So f of 0 is natural log of 27. So that's why we got there. Alright? And local maximum, and you can see that this guy just keeps on increasing, so there is no local maximum, so it does not exist. Alright? So let's go to the part C. So go up here. Alright, so we want to find the inflection point. Let's do that. Alright, let's say part C, we want to find the inflection point, so we have to take another derivative. So f double prime of x is equal to, right, using the quotient rule, we can square the bottom, so you have that, 27. Alright, 4 is just a constant, so I'll just put it in front. And derivative of x cubed is 3x squared. And times the denominator, so x to the fourth plus 27 minus x cubed, and times the derivative of the bottom is 4x cubed. Alright, let's clean this up a bit. Let's see, 4 is still in front. Alright, so we have x squared sitting here and x squared sitting there, so I'll pull that out. Alright, what's left is 3x to the fourth, and 3 times 27, 81, and minus 4x to the fourth from there. Alright, then the same denominator, I forgot to square that. Alright, so this is going to be 4 x squared. And this is going to be 81 minus x to the fourth. Right, so x to the fourth plus 27 squared. Set that equal to 0, and let's see, so it's going to be x equals 0, and also what's 4th root of 81 is 3, so it's a plus or minus 3. Right, so let's do a number line here. Alright, so here's 0, and here's a -3 and a +3. Alright, then you can look at the sign of f double prime. Alright, try something smaller than -3, so -4. Alright, if you plug in -4 here, that's going to be positive, everyone's positive, so you have that. Alright, and if you plug in something between -3 and then 0, so I'll try -1. Right, so that's going to be, oh actually sorry, this is going to be negative, I messed it up. right? So this is actually negative. Sorry about that. Right, but here, negative, that's going to be positive. Everyone's positive. Right, same with x equals 1. 81 minus 1 is positive, so it's everyone's positive. These are always positive because it's squared. And x equals 4, that will give you a negative value. Right, so concave upward would be, so right here, because second derivative positive. So we have from negative 3 to 3. Alright, concave downward would be those guys. So negative infinity to negative 3 and a 3 to infinity. So we got that. Alright, so since concavity changes at these points, right here, concavity change, and there's a concavity change here, there's no concavity change. So you have an inflection point here and an inflection point there. So you have negative 3 and plug in negative 3 into the original function. You get natural log of 108 and a positive 3, and you get the same thing. Alright, that's it. I hope that this was clear.